Good afternoon to everyone. So, I would like to give series lectures on probability and statistics. This is a one subject related to the mathematics, which is for civil engineering second year, second semester students. So, before talking about this subject, firstly, I will introduce myself. My name is Dr. P. Venkat Raman, Professor of Mathematics, Department of Freshman Engineering, Marri Laxman Reddy Institute of Technology and Management, Hyderabad. I did Masters in Applied Mathematics from NIT Warangal and PhD from JNTU Hyderabad. And I am having 29 years of teaching experience and 23 years of research experience and 12 years of administrative experience. In this 29 years of teaching experience, I handled almost all engineering mathematics subjects. So now when we talk about the probability and statistics subject, actually it is a part of the applied mathematics, and as per the R22 regulations under JNTU Hyderabad, this subject is allotted for the civil engineering second year, second semester students. The syllabus of this subject is classified into 5 units. In Unit 1, we discuss about the probability, random variables, and probability distributions. In Unit 2, we discuss about the mathematical expectation, discrete probability distributions. And after that, in Unit 3, we discuss about the continuous probability distributions and fundamental sampling distribution. And in fourth unit, we talk about the estimation and statistical hypothesis, or simply we say this statistical hypothesis as testing of hypothesis. And in last unit, fifth unit, we study about the applied statistics like curve fitting, correlation regression, rank correlation, etc. So the textbooks for this subject is allotted by the JNTU Hyderabad is 3 subjects, 3 textbooks they allotted. First one is Raman H. Meyer, Probability and Statistics for Engineers and Scientists. Second book is famous one in India, S.C. Gupta and V.K. Kapoor, Fundamentals of Mathematical Statistics. And third one is S.D. Sharma, Operations Research. That is also a famous book on operation research in India. Now when we talk about the assessment, the total mark for the subject is allotted for 100 marks, 40 marks for internal and 60 marks for external. So 40 marks we conduct 2 midterm examinations and we take the average of 2 mid exams, and 10 marks are assigned for the assignments and unit tests. So total together 40 marks internal exam and 60 for external examination. Total together 100 marks allotted for this subject. So now we start about the Unit 1. The Unit 1, there are 3 topics are there in Unit 1. The important topics in this unit are, first one, introduction, and second one is probability. What is probability we discuss in this, and what are the related concepts also we discuss with examples. Third one is probability of an event, additive rules or addition rules. And next one, conditional probability. What is conditional probability? After one condition, how to find the probability of one event in the given experiment. So those things we will discuss in conditional probability. After that, product rule and base rule. Product rule and base rule. So these are, we will discuss about these. Next, what is the random variable? Concept of the random variable. Which variables are called the random variables? In this, there are 2 parts, major parts, based on the random variable. So first one is discrete probability distributions. These are defined for the discrete random variable. And second part is continuous probability distributions, and these distributions are defined for continuous random variable. So these are the major important topics in the unit 1. So we discuss one by one. First one is, what is probability? Now, before knowing about the probability, firstly, we know some important basic terms and conditions. Basic terms and definitions, or basic terms and concepts. First one is experiment. What is experiment? So, experiment means it is a repetition of one particular task under homogeneous conditions. Homogeneous condition means same conditions is known as the experiment. For example, tossing a coin. Suppose tossing a coin in a room, because in a room the conditions are same, and suppose if you do that task, then that task is defined as the experiment. And another one is throwing a die. For example, you throw a die, you will get some results. So this is also one experiment. And second definition is random experiment. Random experiment, an experiment in which result is not definite. Result is not definite. So in any experiment, for example, just now I said some examples for the experiment. First one is tossing a coin. In tossing a coin, you may get result as head or you may get tail. But before doing this experiment, will you know the result? Before doing experiment, will you know exact result of the experiment? No, we don't know. So that is called definite. Not definite means unknown. Result is unknown, maybe head or maybe tail. So results we know, we may get head or tail, but before experiment we don't know exact result. So that type of experiment is known as the random experiment. Similarly, in second example, throwing a coin, throwing a die. In throwing a die, we know the results. We may get 1, 2, 3, 4, 5, 6. 6 results we may get any one in throwing a die. But before experiment, we don't know the exact result, which one you will get after experiment. So that is the random experiment. So next, third definition is outcome. What is outcome? But in general, in experiment, in random experiment, in probability, always we take the random experiment only. So from now onwards, experiment means it is random experiment. Now outcome. What is the definition of the outcome? In any random experiment, the outcome, the result of the random experiment is known as the outcome. For example, in tossing a coin, you may get head or you may get tail. So what are the results of this random experiment? Head H, comma, T, tail. So head, tail, these are the two outcomes in the random experiment of tossing a coin. Similarly, throwing a die. In throwing a die, what are the results? 1, 2, 3, 4, 5, 6. So these are the results of the throwing a die, and these are also known as outcomes of the throwing a die. Similarly, for example, 2 coins. I tossed 2 coins at a time. Then what are the results? I may get head head, head tail, tail head, tail tail. So these are the 4 possible results of the tossing 2 coins. So these are the outcomes of the tossing 2 coins. So like that, we can define outcomes to the given random experiment. Similarly, fourth one, sample space, and we denote the sample space by capital S. Sample space is the set of the all outcomes of the random experiment. For example, in tossing a coin, what is the sample space? S is equal to bracket, flower bracket, H comma T or set bracket. Similarly, in throwing die, what is the sample space? S is equal to 1 flower bracket 1, 2, 3, 4, 5, 6. Similarly, tossing two coins, the sample space S is equal to flower bracket HH comma HT comma TH comma TT. So this is the sample space. Next, we talk about the event of the random experiment. So actually event is the any subset. Event is defined as the any subset to the sample space. So in 10th class or intermediate, you know how to write the subsets to the one finite set. So here you have to write all possible subsets to the sample space in any random experiment. Those all subsets are the events. Okay. For example, events are denoted by capital E. Suppose if S is equal to H comma T, sample space, then what are the events? Pi. That means you have to write the subsets to H comma T. Pi, null space, that is null set. Pi is a subset to any subset. Comma next, H, one separate bracket you take. H is a this one, and another T is separate, you take flower bracket T set. This is also subset, and S itself is a subset. So therefore these four are the subsets to the H comma T. So these four are the events. Similarly, you take the sample space S is equal to 1 comma 2 comma 3 comma 4 comma 5 comma 6. Now then what are the events here also? Pi, null set, comma 1, 2, 3, 4, 5, 6, so and so. What is the last subset? S itself is a subset. So in this you can write 36 subsets or 36 events to the sample space S. So here null set pi or event pi is called the null event of S. Now we talk about the list of formulae. Let E is an event of a sample space S, then the probability of E is denoted by P of E and defined as P of E is equal number of favorable points to E divided by total number of sample points. For example, you take S is equal to H comma T in tossing a one coin, single coin. Let E is equal to T, that means tail. Find the probability of E, that is P of E. So here probability of total sample points in sample space 2 here, and how many are favorable to tail? Only 1. So 1 by 2. 1 by 2 is the probability of the event E, that is getting tail. Similarly, example 2, you take S is equal to H, H, T, 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 H, H, T in tossing two coins. Then let event E is equal to T, T. Find the probability of P of E. So here P of E means both are tails. What is the total points in sample space? 4. N of S is equal to 4. And here what is the number of favorable to tail, both tails? Only one is favorable. So 1 by 4. That is 0.25 is the probability. So in other words, we can say this is mathematical definition actually, but in general words, probability is the percentage of happening, percentage of occurring of an event. Percentage. For example, 1 by 4. What is the 1 by 4? 0.25, 25%. 1 by 2, that is 0.5. 0.5 means 50%. So percentage of happening. So it may happen or it may not happen. What is the maximum limit for the happening? 100%. 100% means 1. Probability is 1. And what is the least percentage of happening? 0. 0% means 1. 0. Probability is 0. So from this general definition, we can conclude that probability lies between 0 and 1. If probability of an event is equal to 0, then that event is known as impossible event. If the probability of one event is 1, that event is known as certain event. For example, probability of S. Probability of S is 1. So sample space always a certain event. Similarly, probability of null event always 0. So that is therefore null event is known as impossible event. Similarly, you take another example. Suppose S is equal sample space 1, 2, 3, 4, 5, 6 in throwing a die. Let E is equal event E is equal to even outcomes. Find the probability of E, P of E. What is P of E? Now, what is the total points in sample space? 6 here. 1, 2, 3, 4, 5, 6. So N of S is equal to 6. And how many are favorable to even? Here even numbers how many? 2 is a even number, 4 is a even number, 6 is a even number. So 3 are supporting that the event is even. Therefore, probability of E is equal to favorable points 3 by 6. 3 by 6 means 1 by 2, that is 0.5. So percentage of happening is 50%. You may get even outcome in the throwing a die, that is the chances or percentage of chances is 50%. So these are the and here I have written note 0, probability of E lies between 0 and 1, and probability of E plus probability of E bar complement E complement is equal to 1. Okay, E is the event and E bar is the complement of E. Then probability of E plus probability of E bar is equal to 1. So with this I am stopping here. Next we will discuss another topic. Thank you. Thank you so much.